Okay, welcome back. So today we're gonna continue the questions that we haven't discussed from the last video. Right now we're gonna be looking at section B, question 11. Okay. Diagram 9 shows 5 label cards in box P and 2 label cards in box Q. So there's 2 boxes right here. And 2 cards are picked at random. One from box P and another one from box Q. Okay, so right now we're gonna list out the sample space. So let's do that. So sample space is basically all the possible outcomes. So yeah, we're gonna write it out. Let me be lazy here. Okay. So first let's start with C and then 1 and then C 9. Okay, so basically we just have to follow this pattern with different alphabets in box P with the rest of it. So yeah. And lastly D9. Okay, that's all. So we have 10 possible outcomes in total. That is the sample space. Okay, right now we're gonna continue to the next one. Okay, now we're gonna list all the possible outcomes for the following event from 1 and 2. And we're gonna find the probability also based on the events. Okay, so for the first one is the code that has a combination of consonant or multiple of 3. Uses the word or, so that means in this code we can have both consonant and multiple of 3, or we just have the consonant and the other one is not multiple of 3, and vice versa. Okay, so we're gonna find the probability of that and also list out the possible outcomes. So first of all, we're gonna list out the possible outcomes first. Okay, so first of all, what is consonant? So consonant is basically the alphabets that is not A, E, I, O, U. So it is the exception of A, E, I, O, U. Well, for the A, E, I, O, U, these 5 alphabets are the part of vowel. Okay, so yeah. So we have 1, 2, 3. We have 3 consonant in this box P. And multiple of 3, we have 1 in box Q. So yeah, not A, E, I, O, U. Okay, so right now we're gonna continue. So there's C9 and then B9, D9. Okay, so these 3 outcomes has both consonant and multiple of 3. So right now we're gonna just write consonant only. Okay, so it goes like this: C1, B1, and D1. That's it. Okay, right now we're gonna write multiple of 3 only. So that means the first code is the vowel. And the vowel we have in box P are O and I, so we're gonna write it out. So it's O9, and last one is I9. Yeah. So that's all the possible outcomes. Okay. So right now we're gonna find the probability, right? So it's pretty simple for this. We don't have to do complicated calculations since we already list out all of the possible outcomes and sample space. Okay, so there's total 10 sample space, right? 10 outcomes in here, 10. And how many possible outcomes are in this event? 1, 2, 3, 4, 5, 6, 7, 8. So that's it. We found the probability. That's the probability, 8/10. And that gives us 4/5. And now we have it. Okay, that's pretty simple. Let's continue to the next one. So for the second event, it is the code that has a combination of a vocal. I think it's supposed to be vowel, right? Yeah, I think it's supposed to be vowel, but never mind. Okay, the combination of vowel and number 9. Okay, n. It says n. So this combination must have both vowel and number 9. Okay, so right now we're gonna write out the possible outcomes of this code, this combination. Possible outcomes. So we have the vowel that is O09 and I9. That's all. These are the possible outcomes for the vowel and number 9. So we have 2 here, right? We have 2 possible outcomes. So we just, so for the probability, we just have to write out 2 n over 10. And that gives us 1 over 5. Okay, that's the probability. Okay, let's continue to the C. Question C. State the probability of getting the combination of a vowel and a prime number. Okay, so we already mentioned that prime number is the whole number that can only be divided by itself and also divided by 1 only, right? Only, yeah. So let's look at the box Q. Do we have prime number here? Obviously 1 is not the prime number and 9 is also not the prime number. So that means there's no prime number, 0. Over? Yeah, there's 2 here. There's 2 here out of 5. But we know that everything that times with 0, multiplies with 0, it's just gonna give us 0. So I think we're gonna write it out, right? That's 2 over 5 and times 0 over 2. And that gives us 0. It's not possible because we do not have any prime number in box Q. So this combination is not possible. Okay, so right now we're gonna look at question D. Okay, so it says that the card label number 9 is removed from box Q. Then 2 cards label number 2 and a card label number 0 are put into box Q. So what that means is that the number 9 is removed from box Q, and then 2 number cards are then put into box Q, which are number 2 and number 0. So the new box Q looks like this. 0, 1, and 2. There's the new box Q right there. Okay, so it says that the card is randomly selected from each box P and box Q. So we're gonna list out all the possible outcomes of the event and find the probability of choosing a vowel and a prime number. Okay, so right now we're gonna find the probability of getting a vowel. Okay, so right now we're gonna list out all the possible outcomes first. Okay, so right now we're gonna list out the possible outcomes. So it's similar to the answer from question A, but the difference is that the number cut of the second code will be a little bit different. Okay, so it goes like this: C0, C1, and C2. And the pattern continues to other alphabets as well. And lastly, D2. So that is all of the possible outcomes from this event. Okay, right now we're gonna find the probability of getting a vowel and a prime number. It says that n, right? It uses the word n. So the combination of the code will be like a vowel and a prime number. It has to be both. Okay. So right now we're gonna find the probability of vowel. Let's see. I'm gonna write it here. vowel. So how many vowel we have in box P? Yeah, we have 2 right there. So 2 out of 5. And the probability of prime number. Okay, so we're gonna find prime number from box Q, okay? So 0 is not the prime number, 1 is not, and 2 is the prime number because it can be divided by itself and also divided by 1. Okay, so we have 1 prime number over here. So that's 1 out of 3. And then now we can calculate the probability of getting a vowel and a prime number. So it goes like this. We're gonna multiply it 1 over 3. Okay, now we will get 2 over 15. So that's the probability of getting a vowel and a prime number. Now move on to the next one. This table shows the frequency of 80 dengue fever patients. So this 80, the number 80 here represents the total frequency. It's a total. Okay, so let's see. So based on the data in table 1.1, we're gonna complete table 1.2 in the answer space. So it's right here. Okay, now we're gonna write out the cumulative frequency and the upper boundary. Upper boundary, okay. So what is the meaning of cumulative frequency? Cumulative frequency is basically the frequency that adds up from the one that you are filling in and the one before. Let me show you what I mean. So the first one, normally we just write out what it gives. So it shows that there's 3 in here. We're just gonna continue. And then for this one, it's gonna be 15. Why? Because when it goes from here to here, they're gonna sum it up and then we'll get this. So 3 plus 12, we're gonna get 15. So same goes for here. 15 plus 15, we're gonna get 30. Okay, the pattern goes on and on until it ends. So 30 plus 15, we're gonna get 45. Okay, so 45 plus 13, we will get 58, and then 70, 78, and 80. So it goes through the same pattern. Okay, so right now we're gonna find the upper boundary. So how do we find the upper boundary? So it's basically the middle between the maximum number of the range and the minimum number of the next range. So it's the number between 19 and 20. So how do we find it? So basically just have to sum up 90 and 20 and divide it by 2. And we have 19.5. Same goes to here. So 29 plus 30, we have 2. 29.5. See the pattern here? It goes from, when it goes from this to this, it adds 10. It adds up 10. So that's a pattern when we are calculating the upper boundary. So for the following one, we're just gonna add 10, and so on. So we're gonna have 39.5 right here, 49.5, 59.5, 69.5, 79.5, and finally 89.5. Okay, let's see what is the next question. So for this question B, we're gonna use a graph paper for this. Okay, by using the scale of 2 cm to 10 years on horizontal axis and 2 cm to 10 patients on vertical axis, and we need to draw an object. So what is an object? So object is a freehand graph. What that means is that when you are drawing this graph, you're gonna be just using your hand and a pencil. So it goes something like this, like a sigmoid curve, you name it. So one of the characteristics of an all drive is that you have to add a head to the starting point. So it must have a starting point for that. So let me show you what I mean. Okay, right now we're gonna draw a line. Let's use the other color. Let's use red. Goes from here to here, and then to here. So that's the cumulative frequency, and then this is the upper boundary, UB. Okay. So right now we're gonna plot the points. So it says that it says on the scale that we have to use 2 cm to 10, right? Okay, so let's start with 0. Remember that when we are drawing the graph in this chapter, the 0 we're gonna write it on the horizontal axis right here. So instead of writing it like this, normally we write it like this, right? We're gonna write it here because it's not gonna be starting from 0 at the horizontal axis normally. Okay. Okay, let's say 1 square represents 2 centimeter because this is not the same graph as the one from here, from the exercise book. So it goes to 10 and then 20, 30, and 80. Okay, let's just stop there. Why do we stop at 80? Because the total of the frequency is 80. So yeah, that's the maximum. Okay, right now we're gonna plot out the horizontal axis. Okay, so I just mentioned that we have to add a starting point for an algebra, right? So the minimum upper boundary for the table is 19.5, right? So it's not gonna start there. It's gonna start from the upper boundary before, which is 9.5. Okay. So 9.5 right here, and then 19.5 and 29.5. Yeah, I think that's it because that's the maximum from here. Okay, so right now we're gonna plot out the points. For 19.5, we have 3, and 29.5, 15. So the upper boundary is the X, and cumulative frequency is the Y. So we're just gonna follow this table to plot out the point one by one. So after we plot out all the points, we're gonna connect it together. Okay. So what I mean by starting point is that we're gonna start from y equals to 0. So that's why we're gonna add one more upper boundary to the left. Okay. So it starts from 0, and then we now need to connect it together. Okay, this will take some time, so bear with me. Okay, so after a few tries, this is kind of hard when I'm using drawing tablet. It's easier for me to draw it on paper, so yeah. Okay. So from the algebraic graph, we need to find the median and the interquartile range. So how do we find the median? So first of all, we're gonna find the position of where the median is. So median stands for the half, right? Half of the data. So it's gonna be like this. 102 times 80. The 80 is from the cumulative frequency. And we have 40. So the 40 is not the median, it's the position. Okay? It's from the position. So we're gonna draw a horizontal line from y equals to 40. And then after it touches the graph, it gonna goes down and see what is the coordinate of the x. So the coordinate of the x will be the median. Okay. So let's see. Right here. So it's 40, right? is from 40, and then goes to the right, and then when it touches the graph, it goes down, and it lands right here. So this each small cube represents 1. So 39.5 and then 40.5, then goes on. Then right here is between the 6th and the 7th. So that will give us 48.5, 47.5, 46.5. So it's right in between 45.5 and 46.5. Okay, and then that will give us 46. Okay, so that's 46. And then right now we're gonna find the interquartile range. So the interquartile range is Q3 minus Q1. Okay, so what is Q1? So Q1 is 1/4 times 80, and we have 20. So it's the 20th position. Okay, so it's gonna start from y equals to 20, draw the line, and goes down. And we'll have Q1. And for the Q3, it's 3/4. So that's 60. Okay. We're gonna find it. Okay. So the Q1 is 20, right? So it goes to the right until it touches the graph and lands between that's 30.5, 31.5, 32.5, and 33.5. So it's between 32.5 and 33.5. So that's 33. Okay, that's 33. And then now we're gonna find the Q3. So the Q3 is 60, y equals 60. So it goes to the right and then it touches the graph and goes down and lands between 60.5 and 61.5, and that gives us 61. Okay, so the interquartile range is Q3 minus Q1, so it's 61 minus 33, and we will have 28. So that's it. Okay, so right now we're gonna look at the question 13. Okay, so we have a trapezium JKLM. Okay, so right now we're gonna prove that the area of the shaded area Fx uses Fs to represent the shaded area is s squared plus 2s minus 3. So we're gonna prove it out. Prove the shaded region is this s squared plus 2s minus 3. Okay, so let's see what we have right here. Okay, so we have a triangle here, right angle triangle, and a trapezium. Okay, so there's a right angle triangle inside trapezium. So how do we find shaded area? So we basically just have to find the area of trapezium and then minus it with the area of triangle, and we will have the shaded area. So first of all, let's find the area of trapezium. So I'm gonna write here trapezium. So the area of trapezium is 1/2 times 2s plus 3 and plus 2s, because these two sides are parallel to each other. So yeah, and then times it with the height as minus 1. So right now I'm gonna times 1/2 with this as minus 1. So we will have this, and then continue the operation here. So we have 2s plus 6 plus 2s. Okay, so 1/2s times 4s, we will have 2s squared, and then plus 3s minus 2s, then minus 3. Simplify it, we will have 2s squared plus s minus 3. Okay, so this is the area for the trapezium. And I don't think that we have enough space for this, so I'm gonna write up here area of a triangle. So area of the triangle, okay? So 1 over 2 times base times height, so it's gonna be 2s and s minus 1. So we multiply 1 over 2 and 2s, we will have s, and then s minus 1, s squared minus s, right there. So right now we're gonna find the shaded area. I think I'm gonna write here, so let me write down the area of the trapezium first. So x squared plus s minus 3. Okay, now I'm gonna erase it. Okay. Okay, so right now we're gonna subtract the area of trapezium with area of triangle. So it goes like 2s squared plus s minus 3 minus x squared minus s. So we're gonna throw this negative sign to each of them. We will have 2s squared plus s minus 3 minus x squared plus s. Then we're gonna simplify it and let's see whether it's the same to the answer given above. So 2s squared minus s squared, we have s squared and then 2s and then minus 3. So it's proven. Okay, so fs equals x squared plus 2s minus 3 is proven. Okay. Okay, so right now we're gonna sketch out the graph of this function, and we're gonna mark the x-intercept and y-intercept out. Okay, so let's see what do we have currently. So right now we have the value c right here, which is the y-intercept. So our y-intercept is 0, -3. Okay, so right now we can factorize this equation out. Let me write it here. Equals 0, and then we have s plus 3 and then s minus 2. Oh, sorry, s minus 1. So we have s equals -3 or s equals 1. So these are the x-intercepts. Okay, these are the x-intercepts and also the roots for the graph. So we can mark it up. So it's -3, 0, and what is it? 1, 0. Okay, also we need to find out the axis of symmetry. Okay, so how do we find it? So there's an equation for it. There's a formula. Axis of symmetry. So it's -b/2a. So our b is 2 and our a is 1. So that it will give us -2 divided by 2a. Oh, sorry. 2 times 1. And we will have -1. So this is our axis of symmetry. So what that means is that on s equals -1, the graph will curve. Okay. So let's draw the graph. It will be something like this. Kind of little ugly. Okay, so it's something like this. My hand is kind of shaky. Hope you don't mind. Okay, so axis of symmetry is here. -1, right here. Okay, so let's talk about why is the shape of the graph is in U shape. It's simply because that the value of a in this quadratic equation is 1, which is more than 0, positive. So that's why it's in U shape. Well, on the other hand, if it is less than 0 or negative, it will be an N shape, kinda looks like a reverse U. Yeah, so that's why. Okay, so let's look at the next question. So determine the value of S that represents the shaded area. Okay, so just now we already factorized out this quadratic equation, right? This quadratic equation. So we have x equals -3 or x equals 1. So this answer, this x equals -3 is gonna be ignored, just because the value of x represents the length of this shape. Okay, so the answer is simply x equals 1. So that's it, x equals 1. Okay, x equals 1 centimeter. Okay, so right now we're gonna look at question 14. Okay, so diagram 11 shows trapezium PQRS and WSYZ. Okay, so there are two trapeziums right here. And trapezium WSYZ is the image of trapezium PQRS under the combined transformation NM. Okay, so it says that the bigger trapezium is the image and the smaller one is the object. Okay, so it says that it goes from PQRS to WSYZ. It goes through two transformation, okay, and M. So when you look at the combined transformation, it's not okay, when you look at the combined transformation, it goes through transformation M first and then N. It's not NM, it's MN. So it goes from the right to the left. Okay, so right now we're gonna describe in full, describe detailedly about the transformation M and N. Okay, so for the first transformation M, I think I'm gonna do the rotation of 90 degree. So if you rotate this shape PQRS to 90 degree clockwise, it's gonna be the shape that looks like this, that looks like WSYZ. So let's do that. Okay, so right now we're gonna describe it. So transformation M is the rotation of 90 degree clockwise. We need to mention the center, okay? So I think the center we're gonna make it here, just here. So the shape will look like this. Let's use the red pen. It will look like this. 2, 3, yeah, it will look like this. That's the center. Okay, as center -3, 3. Okay, so this is our first transformation. And then for the next transformation, it's gonna be an enlargement because it goes from smaller size to bigger size, right? So it's an enlargement. Okay, so right now we're gonna write the enlargement. With scale factor of 3. Why is it 3? Because we look at PQ. PQ is the same size as WS, right? although it's not the same length, but it represents the same side. So PQ, the length of it is 2 units. And for WS is 1, 2, 3, 4, 5, 6 units. Okay, so the scale factor is the image divided by object, so that's 3. That gives us 3. So that is the scale factor. At the center, okay, so now let's find the center. So we just have to draw the line from the from one corner to the other corner, which represents the same one. Okay, so let's continue. Let's draw it longer. Yeah, that's about here, and then this represent this. Okay, so 2 lines are enough. So it intersects at here, this point. So this is the center of the enlargement, which is -3, 4. Okay, so -3, 4. So that's the full description of M transformation and transformation N. Okay, so for this kind of question, any possible answers are accepted. Okay, if it gives out the same result, then it is acceptable. Okay, so you don't really have to follow my answer. Okay, so let's hop on to the next one. Okay, so it says that PQRS represents a region of area 100 meters square, and now we're gonna find the WSYZ area in meters square. Okay, so we have a formula for this. Okay, actually before that, we're gonna mention that PQRS. Yeah, PQRS is our object, right? So it represents. So PQRS represents a region of area 100 meters square, right? So that means this is the area of object, and I'm gonna write AO. Okay, so we're gonna find the AI, which is the area of image. Okay, so when area of image is divided by area of object, we will have k squared, because this is an area, so it's gonna be k squared. Okay, so what is the meaning of k? So k represents the scale factor, which is 3 right here. This is the k. Okay, so we have the AO and the k. Okay, so AI equals to 1, AI divided by 100, that will give us 3 squared, and AI equals to 3 squared times 100, that will give us 9 times 100, and that is 900 meters squared. And that's it. That's the answer for it. Okay, so now let's look at question 15. So we are not allowed to use graph paper for this. Okay, so it's gonna be a blank space and you're gonna draw it. Okay, so this is one of the chapters from 3, I think. So yeah, okay, let's look at what we have here. Diagram 12 shows a composite solid made up of 2 right prisms, and ABCD and BCQP are horizontal planes. The surface ABGKF, ABGKF, okay, is MBPST right here, and here. Are corresponding uniform cross-section of each prism. Okay. So it says that the rectangles EFKJ and GHJK are inclined planes. Okay. So JK is 2 cm above the base ABCD, which means that JK is the line right here, right here. Okay. So it says that this line is above the base of 2 centimeter. Okay, and FK equals to GK. Okay, this is the same. And RSTU is the half cylinder. and the rest of these are vertical edges. Okay, so let's see. Draw to full scale the elevation of composite solid on a vertical plane parallel to AP as viewed from X. So we're gonna draw this shape from perspective S, which is here, right here. Okay, so let's draw. So we're gonna start with the line ABP first, right here. So what is the meaning of drawing to full scale? So it basically means that if this says, if it says 4 centimeter, then you're gonna draw 40 centimeter. But since I'm drawing on the drawing board, so it's not gonna be really accurate. So if you are drawing this kind of question, then you're gonna use the ruler, okay, to make sure that it's accurate. Okay, so you will get full marks for it. Okay, so let's draw the ABP line first. So we will have 4 plus 4, 8 centimeter. Right here. Let's say this is 8 centimeter. Let's make it shorter, right here. And then we have vertical plane and 4 centimeter right here. About this long, I guess. This is just an estimation, so don't mind if I do. 4 centimeter and 4 centimeter right here. Right here. Okay. And then we're gonna continue. 5 centimeter right here, so we're gonna draw longer right here. 1 centimeter higher. About here. I think okay. So now we're gonna draw a curve from here. So when you are drawing this on paper, you're gonna use the compass, okay? So what is the radius of this semicircle? Let me show you. Okay, so I'm gonna show you. So it says that this is 4 centimeter, right? Same goes for here. So 4 centimeter is the diameter of this semicircle. So which means the radius is 2 centimeter. And yeah, that's it. I'm gonna mark it out, okay? Okay, that's it. Okay, so now let's continue. It says that there's 2 centimeter here, right? So it's about here, 2 centimeter above, about here. So we're gonna draw it, assemble it like this. So the drawing that I'm drawing, so the drawing is not really accurate. Yeah. So it kind of looks like this. Make sure that all lines are connected. Okay. Okay. So it will look like something like this. Okay. Let's mark it out. 4 centimeter right here. 4 centimeter. And that's 2 centimeter right here for your references. Okay. And right now we have to mark out the points. So we view from X, right? So if I want to, okay, so right now we're gonna mark out the points. Since this elevation, this shape is the view from X, right? From the perspective of X. So when we mark this corner right here, this corner, we're gonna use both of these points, okay? So we're gonna write it like this. So we have P and Q involved. So we're gonna write it like P/Q. The P is the front and the Q is the at the back side. Okay, so we're gonna continue. BC. Okay, so that's it. Okay, so make sure when you are drawing this, you draw it according to the scale, draw it accurately, so you will get full marks from it. Okay. So currently I'm drawing it with my drawing board, so it's not really accurate. So yeah, let's move on. Okay, so right now we're gonna calculate the volume of the composite solid. So basically we have to calculate this whole thing volume. Okay, using pi equals to 22/7. So when pi is involved in the calculation, we're gonna write it with the value 22/7. Okay, we cannot use 3.142 or just simply write it out and type it in the calculator. Okay, so right now we're gonna starting with this. Okay, we're gonna start with the shape on the right. Okay, so it's a prism. It's gonna be simple. We just have to calculate this area right here, and times it with 6 centimeter right here. Okay, so how do we calculate this? Okay, so it says that RSTU is a half cylinder, right? It's a half cylinder. Okay, so it's gonna cut it. We're gonna cut it. Okay. Okay, so we're gonna calculate this area out, right? So we just assume that this is a rectangle, and then we minus out this semicircle, and we just have to times it out with this 6 centimeter, and then we excuse me, and then we will have the answer. Okay, so let's do that. So first of all, we're gonna calculate it out. Volume of the area. Let's call this BPST. So first of all, we calculate out the area of the rectangle, which is 4 times 5, minus out the area of semicircle. I mean, so 1/2 pi r squared. Okay, because it's semicircle, it's half of the circle, so that's why we need 1/2. 1/2 pi r squared. So 22/7, and our radius is 2 squared. Okay, so we have 20 minus I think let's we need to calculate the volume, right? So we just have to let's do it in one equation. Yeah, so we just have to times the 6 here. Okay, make sure that this is covered with bracket because we're gonna solve this equation here first. So 20 minus 2 squared is 4. 2 squared is 4, and then times it with 1/2, we will have 2, right? And then 2 times 22/7, we will have we will have 44/7. 7 times 6, and then 20 minus 6, and then times 6, and we will have 82 and 2/7. Okay, so that's the volume of this shape right here, this shape. Okay, right now we're gonna calculate the volume of this left prism. Okay, so this is a trapezium. If you can see, this is a trapezium, and then these two are equal. So basically we just have to calculate the area first with the trapezium formula, and then times 2, which should give us this volume, I mean this area, and then we just times it with 6 centimeter because it's the length of it, and we will have the area. That's it. Okay, so right now we're gonna calculate it. Volume, let's call it, you know what, let me just call it left prism, so it's easier to understand. And maybe I should change it to right prism right here. Right right prism. Okay, so we're gonna calculate out the area first. Okay, so 2 times, right now we're gonna use the trapezium formula, 1/2 times a plus b, which is 2 plus 4, because of these two parallel sides. Okay, and then times it with the height, which is here, half of the 4 centimeter, which is 2 also. That's 2. Okay, and then times it with 6, and we shall have it. So 1/2 times 2, we will have 1. 1 times 2 plus 4, 6. So we will have 2 times 6 times 6. Okay, so that will give us 72. And now we just have to add it all together and we will have the final answer. Volume of composite solid and we will have 154 and 207 centimeter cube, and that is the volume of this composite solid right here. Okay, so on the next video we will be discussing the rest of the questions, because session B takes a little much longer than I expected. So we're gonna split this into 3 parts, okay? This whole discussion. So since I already uploaded the part 1, and now part 2 will be for the session B, and then part 3 will be for the session C. So see you guys next time. Goodbye.